Hello, myself MD Foderabi. Today I will present on MOSFET characteristic and switching behavior, which is one of the most important topic in power electronics and modern semiconductor technology. Understanding MOSFET operation helps us design efficient circuit, especially for switching, amplification, and digital logic. First of all, what is MOSFET? A MOSFET is a semiconductor device used for switching and amplifying electronic signals. It has extremely high input impedance, gate insulated by silicon dioxide, requiring virtual no input currents. It has four key terminals: gate, it controls the channels, then drain, the currents leaves here, then the source, the currents enters here, the body usually tied to source. There are two types of MOSFET operations. First of all, enhancement mode MOSFET normally off, and the depletion mode MOSFET normally on, and based on the carrier type and MOS and PMOS. Now I am going to tell shortly how MOSFET works. The gate is insulated, so no currents flow into the gate when the applied voltage is VGS. Instead, the voltage create an electric field. The electric field attract charge carrier and form conductive channels between the drain and the source. Depending on MOSFET types and MOSFET and channel MOSFET, the channels forms with electrons, and the P channel MOSFET, the channel forms with holes. Once the channels forms, applying VDS lets currents flow through the MOSFETs. The MOSFET turns on or off if the VGS is less than VTS. VTS is a threshold voltage. Threshold voltage means the values of VGS at which a sufficient number of mobile electrons accumulate in the channels regions to form a conducting channels is called the threshold voltage, is denoted to VT. So when the VGS is less than the VGS, there is no channels form, so the MOSFET is off. If the VGS is greater than VTS, the channels form, so the MOSFET is on. DC characteristic operation regions. There are three regions or three major regions depending on the gate to source voltage and the drain to source voltage. First of all, the cutoff region. When the VGS is less than the VTS, the threshold voltage, the MOSFET is off, and so the channels is formed. The ID, the means is the drain current is equal to 0. When it is the triode region, when the VGS is greater than VTS and VDS is small, the MOSFET behave like a variable resistor. It is useful for analog control. The last one is the saturation region. When VGS is greater than the VTS and the VDS is large, the ID, the drain currents becomes almost constant. The MOSFET acts like a current source. It is used in the applications. The IB characteristic curves. There are two curves. The A is transfer characteristic and the B is output characteristics. If I told about transfer characteristic curves, it is IDS and versus VGS curve. Transfer characteristic shows how the drain current ID varies with the gate to the source voltage when the drain to source voltage is constant. When the VGS is less than the VTS, VTS is threshold voltage, the MOSFET is off, so the drain current is equal to 0. When the VGS is greater than or equal to VTS, the channels is formed and ID is increased. So the sharp shape of the curves very flat at the first because the MOSFET is off, and sharp rise after VGS is equal to VTS. The parabolic growth is saturation region. In saturation region, then the MOSFET, then we can use MOSFET as a switch. Condition is when VGS is equal to 0 or less than VTS, the MOSFET is off, the off state, and we can say that it is cutoff region. So the ID is equal to 0, the drain current is equal to 0, and for on state, the VGS is greater than the VTS. Result, the channel is fully inverted, acting as a low resistance path. Application of MOSFET. We can use MOSFET in different kinds of sectors like power supplies, laptops, phone chargers, then motors drivers, microprocessor, then LED drivers, and RF amplifiers. Thank you.